Hello everybody, this is Jasmina, and in this video I'm going to talk about a separate way to measure true north at your location, and this will help you determine the facing direction of your house. Of course, this is why we do this, and this is a little bit more straightforward in one sense, although it does require some knowledge of geometry. But if you have a window that receives direct sunlight at your local solar noon, you can measure true north directly and more accurately than you can with a satellite, because the satellite image is never super clear, and sometimes perhaps if you've got a lot of trees around your house and you can't really see the edge of your house very well, it can be really hard to determine exactly where the edge of your roof is and where the edge of your house is and things like this. It can be a bit difficult, but this is very accurate and a real true measurement, because we're using the sun to do this. Now it's based on using your local solar noon and down to the second and down to your exact location on Earth. With the, that is the latitude and longitude. Now, the advantage of this is you do not need to correct the UTM to true north because you are measuring it using the sun directly. So there is no UTM error. Now, the downside is if you don't have an appropriately facing window, you would have to do this outside the building, and it's quite complicated and would require a pretty fussy setup. So I would recommend you don't bother with it. You use the satellite instead. And there you would have to do that UTM to true north correction because the satellite uses UTM north. Now it will require a little bit of information and a few tools. You need a level. Actually, you probably need two levels. And you need some painter's tape, and perhaps some opaque tape. Painter's tape is semi-opaque, but it may be good enough. And you also need a protractor. A larger one is better, it's more accurate, and an accurate clock. One example is an app called Time Is. You also need your exact location, your latitude and longitude, and you can find that here, and you can just stick in lat, lon, finder, and this will pop up first. I've never seen it not pop up first, and it's accurate, so that's good. At solar noon, the shadows in the northern hemisphere will point true north during the December solstice, and in the southern hemisphere they will point true south at the June solstice. And this is true even if you're in the tropics or you're outside the tropics. This is definitely true. Now, outside the tropics, that is, if you're in the northern hemisphere and your latitude is above positive 23.5 degrees north, then the shadows will always point true north regardless of the time of the year. It doesn't matter. It will always point true north. And outside the tropics, that is farther to the south, and it's usually a negative 23 is what, that's how they indicate south, 23.5 degrees, then your shadows will always point true south. Again, regardless of what day it is. And of course, during these times, this will be where the shadows are the longest, but if you're up in Alaska and you wait for winter solstice, you may not have much sun to deal with. It could be too dark. If you're above the Arctic Circle, you won't have any light. So you have to know what you're doing, of course. Now here again, there is no UTM to true north correction needed because you're measuring using the sun, which is, again, measuring true north or true south. Now, if you do have site plans, this could be more accurate, but how accurate they actually build your house is sometimes a bit of a question. So, and there you would still have to use the UTM to true north in your plans because the site plans also use UTM north, not true north. But this method here can be used to check to make sure that your plans are correct. And this is, something you can do. Of course, you have to go kind of backwards with the true north to UTM correction, so it's a little tough. But, you can check it. Now, there is a NOAA website, and this is the National Oceanographic and Atmospheric Administration, I believe. It has this website. I will try to remember to put that in the link below because it's pretty complicated. This allows you to enter your residence's latitude and longitude and your time zone to find the time of your solar noon for all days of the year. And that's the year we're currently living in, of course. It could vary a bit from year to year, so check this whenever you want to do it, check that year. Now, if you add that data listed here and you have to scroll down a little, you will see something that looks like this. This is a screenshot, so it exactly will look like this, or at least it did when I got to the page. And it says create sunrise sunset tables for the year. Click on that. And as it says, a new window or tab will open, and that's true. And this new window will contain not just the sunset and sunrise times, it will also contain the local time solar noon, down to the second for all days of the year. So this is why this is so useful, because you can do this at any point in time. So this is another screenshot from the thing. Now you are given 3 sets of data. The solar noon is the last set, so you have to scroll down quite a bit before you get to it. But this is a actual, for my particular location, this is the actual solar time. And you just have to check and find the day. And of course, you just scroll down till you get to the day, but you got January, February, all this. These are, of course, Gregorian dates. And again, this is just another screenshot. So, and you will see this exactly like this. Cells with light green indicate where daylight saving time is in effect. Now, where I live, we don't have daylight savings. So that won't happen for me, but it may well happen for you. Now, you do need to prepare the location where you're going to take this measurement before solar noon comes. And actually, you may even start a day before, get everything kind of set up. Now you will have only 1 second to make the most accurate measurement. So this is why it's best if you can have 2 people. One will actually count down until where you need to place it, and you keep adjusting the tape as the sun moves, and you start maybe 5 seconds before the time and of solar noon, and just get ready, and when they say now, stick it down. So that will give you the most accurate thing. Now I am assuming, but before you get there, this is what you have to do. I'm assuming you know how to use a level defined vertical, that is plumb, straight up and down. If you don't know how to do that, Google something to help you with this. And what you need to do is you need to find something that is hopefully in either your door or your window that is plumb. If you don't have that, you can actually create something, which I'll cover in a bit. But I would recommend you have a decently long level. 3 feet is a really good size level, and it's pretty standard. But if your window is less than that, it's whatever fits in your window. And if you have a big window, I don't think you need anything more than 3 feet long. That will be fine. Now, you also, the nice thing is if you actually have your windows really nicely straight up and down, and typically they're that way, unless the house is very, very old and it has shifted and things have moved a bit. But if you can use the edge of a window or a door if it is plumb, and you measured that, of course, with your level. That is the easiest way. If it is off, then you have to do something else. You can place the level against the wall, and I would hold it with two hands to make sure it doesn't move, because it probably has a tendency to want to, and then have somebody else lay a piece of tape on the window, and it has to be opaque tape so that you create a shadow, using the level as a guide. Now you need to make sure that the tape is up against the edge of your level when the level is in the plumb position, and it doesn't overlap or gap from that edge. And that may take a few times to do to get it right, because it's a little tricky. And this tape should be relatively long so that you've got a really good idea of, or you'll be able to get the shadow where you need it. If it's too short, sometimes the shadow isn't where you can measure it. I mean, that's what I'm worried about. But then you just do it again with another piece of tape in an appropriate area. Now, you will also need to see if your windowsill is level in both directions, that is, from side to side and inside to outside. There are some short levels. Some are as short as 3 inches. 6 inches is probably okay. Trying to measure from the inside out with a 3-foot level is a little bit hard to see if it's level, because it has a really easy tendency to want to rock, so to shift too much. You can just put a smaller one and just set it on the windowsill from perpendicular to the opening, and let it settle, and it is pretty easy to measure. Now, if the inside sill is not level, then I would recommend you just use the satellite. Again, you still have to make the UTM to true north correction, but at least it is, you don't have to fiddle, and you don't have to create a level sill. And you need to have a level sill. If it's not level, you are not going to have a good measurement. Now, a non-level inside sill can be corrected for, but it's fiddly, really a lot of work to do. And if you don't understand how to do it properly without instructions, you're probably going to have a really hard time doing it properly at all. So I recommend you don't bother. That's, you just use the satellite. Now, this method that I'm going to show you revolves placing the edge of painter's tape along the edge of the shadow at your local solar noon, and that's down to the second, because the sun moves surprisingly fast. Now, you can take the measurement from the window frame if you have an appropriate type of protractor, or you can create a parallel line to your window frame for a more standard type of protractor. Now, this does assume that your window is in line with the wall, and that's normal. I mean, it would, but there could be slight deviations. I wouldn't be too worried about them. It's okay. Now, for any type of protractor, you can place a piece of painter's tape a fixed distance from the window, and you measure that fixed distance at least 3 places. It's better if it's more like 5 places, and you align the tape on the marks. And the reason why I keep mentioning painter's tape is if you have a painted windowsill, the painter's tape will come off without ripping the paint off. There is other types of tape that will actually rip, it could rip the paint off, and then you have to repaint, and it's a big pain. Painter's tape is just safer, and it's adequate, and it's not terribly expensive. Now, it is the window frame you're measuring from, not the moving parts of the window. So it's that piece of metal or whatever it is. It could be vinyl. It could be even fiberglass nowadays. It's from that part that actually touches the walls, not the moving window part. And this is easiest to do after you've made the measurement of the solar noon, and even better if you have a different color of painter's tape, because then you can see the two things more distinctly. Now, a few minutes before solar noon comes, you should start getting prepared to mark the position of the shadow. So make sure you have enough painter's tape that basically it covers enough of the windowsill. And you get an app ready, like Time Is or whatever. You don't need to do this. They're not paying me. But anything that has a clock time down to the second and based on something like an atomic clock. So you know you're accurate. And the NOAA website, again, is going to give you the clock time of your houses because you're putting in your house's latitude and longitude. It will tell you your house's solar noon. And you're going to place the edge of the painter's tape along the edge of the shadow on your windowsill at your local solar noon. Down to the second if you can. Now it is a lot easier to measure later if that piece of tape covers the total part of your windowsill with that one single piece of tape. It's just easier to make the measurement later, that's all. But if you've screwed up, you may still be able to measure it. It's just going to be a little harder. Now, once the painter tape is down, measure that at the solar noon, your local solar noon, you can then measure at your leisure the angle that the tape makes with the facing of your wall. That is basically the frame of your window. Now, cell phones and computers, at least this has been my experience, they no longer standardly do seconds. But this website, Time is pretty good. It seems to either Central Time Zone or maybe you said it, I don't remember which. But the NOAA is the place where you're going to get your solar noon on that clock, which is going to be this clock or the similar. And if you really want to be absolutely certain, you can check several days during the year so that you're making sure you're doing the measurement correctly. And it will result in the same angle if you're doing it properly. It's because we're basing it on the sun. And that has to do with how we are revolving around the sun. And it's very, very accurate. Now, the wall, this is one very important thing. The wall that you're going to be measuring, that facing direction of, does not need to be your facing wall. Doesn't need to be the facing wall of the entire house. But you do need to know the relative direction between this wall that the sun is coming in on and your facing wall. So most of the time this is pretty straightforward. Most houses have 90 or perhaps 45-degree angles. They're much easier to build, and that's why they usually do it this way. But if your outside walls are circular or curved or something weird, then use a satellite or a floor plan with a north arrow. That's even better. But sometimes you have it, sometimes you don't. But the satellite is something that you can use. You have to understand where you're facing in general. By looking at the satellite, you still need to know where you are. That is what you determine your facing direction to be with respect to the house. But I think this is not that difficult to understand. Now I'm going to give two examples here with this using the sun. One is in the northern hemisphere and it's outside the tropics, and the other is in the southern hemisphere, which is fake. It's not real, but I'm just showing it as an example. And but you need to understand which directions your shadow faces. So if you're in the tropics, it gets complicated. If you're outside the tropics, it's simple. So here is for the northern hemisphere, and this tape was laid down like 2 to 3 seconds after the solar noon. I didn't have someone to count down the seconds, so I was watching the clock and then came over, and then I realized I had to adjust it, and it was not exactly solar noon. It's close. And you can see there's some wrinkles here. It's because painter's tape stretches a little, which is fine. You want this to be taut, not really stretched, but definitely straight and not like wrinkled or anything when you lay it down. Now, the photo was taken, probably about a minute after the tape was laid down. And that's because my camera turned off, and so I had to turn it back on. And you can already see that the shadow has moved a little bit. This is why we go down to the second. Now, this is a very accurate and not cheap protractor, but it can get quite accurate. And this is the photo is a little blurry, but you can read it with your own eyes in real life. It's not too bad. And it measures 60.4 degrees. And this is pushed up against the window frame. Now there is, of course, a little bit of caulk here, so it's above the caulk. So it's right against the window frame. And then this is along the edge of the tape. And you can't see it because it's right over the tape line. And that's how you measure it accurately. And so this is a blow up. It's still blurry because the photograph isn't super clear. But I could see it, again, with my own eyes. And that's what it reads. Now here's a different version of a protractor. It does have a nice line here, so it helps you line up with the edge of the tape. The little X there, that's got a hole in the middle, that has to be where the tape, the parallel tape, and the tape measuring the angle meet. This is why it's nice if you can have a separate color. It's hard to see here, but you can see it easier in real life, the edge of this tape. It is visible. It's just a lot easier if it's a different color. Now, you of course have to line that up properly, and then this thing will rotate until you reach the right angle. This one is not as easy to use. It's a little fiddly, but it does work. And it basically is 60.5 degrees. It's really hard to tell because this is smaller, a little harder for it to measure. So let's go to the example, the one that I actually had measured with the 60.4 degrees. This is what was measured. This by geometry is the same distance, and this is 90 degrees, and so we know what this is. So this is in the northern hemisphere, so we know the shadow is pointing true north. So this measurement here is the measurement that will tell you the facing direction of the wall. So it's 180 plus 29.6 degrees. So this is a southwest one facing house, and this is my house. This is my facing direction. My compass says it's south, smack dab almost in the middle of south, or like 170 something. Compasses are so bad. Please don't use a compass. But yeah, I should really put my compass reading beside this. Totally messed up. That is in part because we have about a 10-degree declination. So it's going to be off by 10 degrees anyway. But it really is far off. Now, remember, that wall that we measured, the one the sun comes in at, does not need to be your facing wall. It just has to be able to get the sunlight into your house at solar noon. So if this were your house and you had a road out here on the right side, your wall, this facing wall, would be northwest 1. If instead you were facing this direction, you had the road out here or maybe a beautiful lake or whatever, then you would be northeast 1. If it was facing this wall here on the left side was the facing wall, then it would be southeast 1. And if it was the original one, it would be southwest 1. And this is our facing. It just happens to be facing the same direction as where we can take a measurement. Now, I put down this tape, and I did this deliberately, either 90 or maybe 2 minutes before the local solar noon, because I wanted to show you how much it can move. So I put this down at the edge, and you can put the tape along this edge of the shadow or this edge, it doesn't matter. Either one is fine. It can work, but you have to measure along whichever side you chose when you laid the tape down. This is a little hard to see. There is some wrinkles here too because this was the edge I laid down. Now, this photograph was a few seconds after solar noon. I mean, not a few seconds, at least a minute after solar noon, because again, I took the picture of the other stuff first. And you can see that this has moved quite a bit. And this is only maybe 2-3 minutes at the most. And it will be how much it moves here is more than how much it moves here. That's normal. That's the way it works. So you can you can see that this is why we care about the second, is because it can mess up your measurement if you only use the minute. And of course, this is why I like you to have two people, somebody counting down the second, so you can put the tape down immediately. Now, this is an example for the Southern Hemisphere. It is totally fake, completely fake. This is my house still. I just am not going to fly down to the Southern Hemisphere to do this. And I just did this very quickly, didn't bother to, be super fussy. But you do basically the same thing. And this, again, this picture is a few seconds, minute or so after I laid down the tape, because it takes time for me to get the camera ready. And but I lay that right over, and I just use the edge of the windowsill here because it's a super quick measurement. And it reads 116.7 degrees. That was actually not that terribly hard to read. But so this is what we have. And so we know that this angle here is, because this is in line, we know that this has to be whatever this measurement is plus 90 degrees. You have to have some geometry. And we also have this here. We also know what this is. Now this is north going up and to the right. Because this is south. Because this is in the Southern Hemisphere, everything points true south. And so this is 360. Because this is north, you would have to measure around this way. So it's 360 minus that 26.7 degrees. So this is a northwest 3 facing wall. You could instead take the 180 plus 153.3 degrees, you're going to get the same answer. It's all just simple geometry. Hopefully this isn't beyond people's capability. And I bet you thought you would never use your high school geometry or even your middle school geometry again. Here's an example. So, summarizing it. First, you check for plumb of the window or the door and level of the windowsill. If you don't have these two things, basically use the satellite. You can create a plumb line on the window or a glass door. It would have to be glass because you have to get light through. But you could create a plumb line there, but it's easier if the window is already plumb. Then you determine your local solar noon from the NOAA website, and you need your actual latitude and longitude of your house, and that's not that hard to find. Latin Lawn Finder does it. Have someone help you with a countdown to your local solar noon. This is pretty important because it takes you a bit of time to be able to do this. You have to be ready to put the tape down at the right second. And you would be placing a piece of painter's tape along the edge of the shadow as close to the second of solar noon as you possibly can. Then you measure the angle between the window frame or a piece of tape a fixed distance from the window frame and the shadow or the tape, actually, the actual position of the tape. And you don't have to do it immediately. It's when you have a chance. And then you use geometry to determine the facing direction of that wall. And because you know how your facing wall is with respect to this particular wall, which will have to be either a north or a south facing wall, and depending on which hemisphere you're in, uh, that is how you can determine the facing direction of your house. So that's it. I hope this was helpful and gives you another way to measure this that is really very, very accurate, and you don't have to worry about the UTM to true north correction. So it just makes it easier, at least in my book. And I really like this method. It is completely accurate because it's relying on the sun. Thanks again for watching.